Hi, I want to talk today about derating conductors for extreme circumstances. So more specifically, what I want to talk about today is derating conductors based on more than 3 conductors installed in a conduit or cable and passing through an area or terminated in an area which is exceeding a 30-degree ambient temperature. So our basic defaults as we're working through code problems or sizing stuff in the field, right? We typically would assume it's not exceeding 30 degrees ambient temperature. We also typically assume that the conductor is not installed in a conduit with any more than 3, which would allow us just to go right to table 2, which is not more than 3 conductors in a conduit and 30-degree ambient temperature. What we have to do if we exceed 30 degrees or if we exceed 3 conductors in a conduit is we have to take into account the extra heat. So if I have a conduit with more than 3 conductors, I'm going to produce extra heat in that conduit. Just like if I run through an area or terminate in an area above 30 degrees, there's going to be extra heat present. So what we want to do is we need to basically derate our conductors, saying, okay, well, I'm going to need a bigger conductor for my load because I'm putting it through extra heat. And then what I need to do is I need to say, well, now that I've selected this bigger conductor, what is it actually good for based on the heat and size my overcurrent device? So that's what we're going to do today. We're going to talk about the load, size the wire for that load based on the conditions that we're in, and then size an overcurrent device. Right, so some rules that we are going to visit along the way. The first thing is 4004. Today we are going to talk about copper conductors, RW90, 75-degree termination temperature, and it's a non-continuous load. We'll assume we're installing it in just a rigid steel conduit. So we're going to use 4004. It tells us some things, right? It tells us we need to size the conductor based on the load. It also tells us that if we have a high ambient temperature, we need to go to table 5A, and it tells us that if we have more than 3 conductors, we need to visit table 5C. So this is kind of the process that we would follow. We use this little diagram. We go up, size our wire bigger, and then size our overcurrent back down to where we were. So how this works, I take my load. In this case, I have a 400 amp load in a conduit with 6 conductors total, meaning there's 6 conductors in the conduit, and it passes through a 35-degree room. So I'm going to take my load, which is 400 amps. Perfect. Under normal conditions, I would just size my wire and my breaker, I'd be good to go. But because we're running through this 35-degree room, I need to get a derating factor. And I'm going to get my derating factor for ambient temperature from table 5A. I'm going to base this derating factor on my 35 degrees. And I'm going to use the 75-degree column in table 5A because I have 75-degree termination temperatures. It tells me I'm going to use a derating factor of 0.94. That's my derating factor, my demand factor. I also need to visit table 5C. Now, table 5C gives me my demand factors for when I have more than 3 conductors in a conduit. So I go to the table. When I have 6 conductors total in a conduit, 6 conductors in this case, tells me I need to use a derating factor of 0.8. So what I have to do is I have to take my 400 amps and I'm going to divide up, meaning I'm going to take 400 amps divided by 0.94 divided by 0.8. The reason I'm dividing is I'm expecting a bigger number, right? I need a bigger wire to carry my load. This, when I divide up, just like this, I get a number, divide up, I get a number right here on this diagram, which is called my minimum ampacity. Now the minimum ampacity is how much current does my wire have to be able to carry. So in this case, we go 400 divided by 0.94 divided by 0.8 gives me 531.9 amps. 531.9 amps is my minimum ampacity. Now I'm going to size my wire. So I take that wire. I'm going to go to table 2, specifically the 75-degree column. Because I have 75-degree termination temperatures, go to the 75-degree column. That gives me a 1,000 kc mil conductor, which is typically good for 545 amps. But under these conditions, this 1,000 kc mil is no longer going to be good for 545 amps. So now what I have to do is so I derated my load, found my minimum ampacity. Now I need to take this conductor and derate it to find out what is the new allowable ampacity of this conductor. So to find my number, I am going to take these and I'm actually going to multiply my way back down. So I take the original allowable ampacity of my conductor, 545 amps. Now I'm going to multiply it by my derating factors. Multiply by 0.94 for my temperature. Multiply 0.8 for my 6 conductors in the conduit. Now this gives me 409.8 amps. That is the allowable ampacity. That number is right here. Allowable The allowable ampacity is how much current can I put on this conductor under these conditions. So under the conditions of 6 conductors in a conduit in a 35-degree room, I can put 409.8 amps on that conductor, which is good because I only have a 400 amp load, so I'm good to go. Our very last step in this process would be to size the overcurrent device. So I have my load. I've sized my wire. My wire is good for 409.8. What I want to do when I size my overcurrent device is I'm using 14104 is the rule. Now 14104 tells me to size my overcurrent device based on table 13. It says if that overcurrent device is not available, you can select based on the ranges on table 13. So when I go to table 13, when I go to table 13, a 409.8 amp overcurrent device is not available. Therefore, in this case, I would end up with a 450 amp OC. Now this would be my max OC. So in this case, we determined the minimum conductor size and the maximum overcurrent size. So again, I hope this video was helpful. We were determining the derating factors based on more than 3 conductors in a conduit and higher than 30-degree ambient temperature, right? And if you only have one of the two, then you only need to apply one of those 2 demand factors, and it'll end up at the exact same way. Or it'll get you the right answer. I hope this helped. Make sure you check out the other videos. Thanks.